Welcome to my channel Educational Wisdom. Today we will discuss properties of waves, reflection, refraction and diffraction. Reflection of waves. When waves moving in one medium fall on the surface of another medium, they bounce back into the first medium such that the angle of incidence is equal to the angle of reflection. This is ray diagram of reflection of waves. The angle between incident ray and normal line is called angle of incidence. The angle between reflected ray and normal line is called angle of reflection. Two laws of reflection, I. The incident ray, the normal, and the reflected ray at the point of incidence all lie in the same plane. E. The angle of incidence is equal to the angle of reflection, i.e., I equals R. Example of reflection. We see a page of a book because light reflects from each part of the page in all directions, so that some of the light rays from each part of the page enter our eye. Because almost no light is reflected by the printed words, we see them as black areas. Refraction of waves. When a wave from one medium enters into the second medium at some angle, its direction of travel changes. In refraction, the speed of light changes due to change in the wavelength. But frequency and hence the color of light does not change. This is ray diagram of refraction. The angle between incident ray and normal line is called angle of refraction. The angle between refracted ray and normal line is called angle of refraction. Two laws of refraction, I. The incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane. E. The ratio of the sine of the angle of incidence, I, to the sine of the angle of refraction, R, is always equal to a constant, i.e., sin R equals constant equals n, where the ratio sin R is known as the refractive index of the second medium with respect to the first medium. So we have sin R equals n. It is called Snell's law. Example of refraction. Bending of pencil in water is due to refraction of light. Diffraction of waves. The bending or spreading of waves around the sharp edges or corners of obstacles or slits is called diffraction. Diffraction of waves can only be observed clearly if the size of the obstacle is comparable, equal, with the wavelength of the wave. Clear diffraction phenomenon. After passing through a small slit between the two obstacles, the waves will spread in every direction and change into almost semicircular pattern. Little diffraction phenomenon. Diffraction of waves while passing through a slit with size larger than the wavelength of the wave. Only a small diffraction occurs near the corners of the obstacle. Test yourself. In this picture you can see clearly the image of a lion formed inside the pond water. Can you tell which phenomenon of physics is involved here? Test yourself. Why the position of fish inside the water seems to be at less depth than that of its actual position. Test yourself. You can listen to your friend behind a corner but you can't see him, her. Why?